hate these meeting emails. Either I get like 5 of them or none.
Yes.
Extension of exercise.
Uh-oh. I think my the meeting officially only starts at 10:15.
Okay, no problem. Just waiting. No problem. Thank you.
Recording now. Hello, everybody. So we're probably just getting started. So please put in your names onto the meeting notes.
Want to wait a couple minutes more? There's almost nobody on.
There's a few people.
Oh.
Yeah, let's wait a few more minutes. But at the same time, put in your names on the attendees and your company. So I think we can start with tracking and work items. Galley and prototyping, and so I put the child bugs and from the master bugs, and so we can track them separately. So odds, how's the progress with alpha model config?
Not much. I've spent a lot of time trying to figure out the nice testing strategy for ourselves, trying to get the trying to use the Kubernetes testing framework. I almost spent probably more than 2 days on that one, and I just gave up. It's just like it's a dependency hell. And I was dealing with mixer-related stuff, so I really didn't spend too much time other than that.
Okay, so what the plan is now, given the Kubernetes testing infrastructures?
Mocks.
Okay, just no mocks.
Like we can't even use their mocks because they're part of their testing framework. They actually have no mocks for this purpose. I have to build our own mocks.
Okay, and like we talked about previously, maybe this will just fix itself as we move forward, dependency-wise.
Maybe. I would love to have that because their framework allows us to start an API server locally in process, right? And then we can run tests against it. That's just great unit testing story.
Yeah.
And it's just that it pulls in API server itself as a dependency, which is a huge dependency, and it seems to have some conflicting dependency sets with whatever we have today. I tried like wading through them, trying to fix them, like adding constraints, and make it happen.
Too bad.
Okay, and so the format-wise, so I'm still working on the pilot refactor. This refactor is fairly deep, so I kind of split it into 3 steps. I just merged the first step, and I'm gonna change the client, and the next step we're changing the storage model. So it's also in progress. And I didn't really get into the design public internal format. At this moment, it's pretty much different API groups, and that's it. Prototyping the OS config. And so Dim and I just talked about how we're going to roll out the OS config, and we had some discussion and shared some ideas. So I would say the rollout is in progress and the design. And we also made some decision how the format representing the cluster namespace scope. We decide to align with Kubernetes RBAC, like having cluster roles and roles for name scoped, and the cluster roles for the cluster scope config.
Yeah.
I also sent the PR to the Istio API, but we have some people not agree with that, and I need just coming down. So besides that, I think Dim is still working on the config spec API. He has a PR updating the OS config, and that's ongoing. As last week, we had a review with Kubernetes about how we Istio config gonna upgrade. I haven't heard from Winsong yet. See how his prototyping status. I will check with him. API style-wise, as I said, the pilot refactor is in progress. If that is done, we are able to have namespace have the package and path mapped Kubernetes API group for all the resources for pilots. And after that, we're gonna see how we can do for Mixer. Not too much progress on the validators and the linters, and not really any work has actually started. So on the validator part, but at least Mate and I talked that we're sorting out that we will using some validators for the doc generation, but probably not too much beyond that. So Jason, you wanna giving updates on the P0 thing?
For the big validator?
Yes.
So we have code in place for pilot and code in place for Mixer to do CRD validation through webhooks, but they're not unified. So they're not. I'm not sure if the Mixer code is actually enabled because of dependencies with Kubernetes not supporting it until very recently. So again, most of the codes there.
Actually, quite difficult to hear you.
Oh, where's the mic down here?
Yeah. Code is present, but it's not turned on by default. And we need to unify the webhooks between pilot and Mixer as well, eventually, once there is a Kali thing to put it into.
Mhm.
Longer term, some of the code that's being called through these webhooks could be auto-generated from some of the OpenAPI specs or validation code from the protobots, but right now it's all manually written. So lots of incremental improvements to get that where it needs to be.
So any questions or any work item I have missed? Questions from the community? Okay.
Actually, I have one question on that.
Okay, go ahead.
Maybe it's a development thing, but
Maybe it's more of a development question, but do we want to move validation out of pilot and out of Mixer and into another thing?
Yeah, I think ultimately once the architecture that we're going to talk about in a minute kind of rolls out, validation moves upstream. So either Galley's going to do some, or the offline tool is going to do some. So by the time it hits the components, ideally the components at runtime just get fresh, clean stuff.
So I don't want to create another component that's then going to be superseded because it's a lot of work.
Yeah, no.
Just update things. So once there's a component that I can put it into, I'll work on unifying the two schemes.
Yeah, as long as what we have now is actually connected.
It's connected, but a lot of the work there isn't writing validator code that exists. It's getting everything plumbed through and getting set up scripts.
Yeah.
And it's kind of tedious work that's very error prone.
Okay.
So to make sure it's plumbed through for setup and tests. And then if we add a new component, you end up having to redo all of it.
I thought June had already wired in the validation for Mixer at least.
It's wired in, but the final integration step to the API server, you're generating certs, and it's simple on paper, but
yeah. All right.
Okay, so if there's no more questions on Tracker, we need to move to the second agenda. Martin will talk about the EC2 config architecture.
All right.
For the rest of, you only have 20 minutes.
Okay.
Could you present? So I will.
You cannot
I
start
would-
sharing while the other participant is sharing. So you need to
Yes,
stop
so let
first.
me drop.
Okay. And then I will do it. Hopefully this will work. All right. You guys see my screen with a diagram? On the call, anybody?
Yep.
All right.
Yeah, we can see it.
Kind of starting to get the hang of this Zoom thing. All right. So we had a meeting sometime in January, I guess, to kind of hash out a number of issues about what we want to do with the config architecture. Since then, I've started this architecture doc and kind of drew this diagram, and the doc is about explaining this diagram and how it all works. So actually, let me go to the previous introductory diagram. So all I want to do is kind of go over these diagrams in 20 minutes and give you a sense of where our collective mind is at this point. So right now in Istio, people write configs by submitting CRDs into a cluster, and the CRDs are component-oriented largely. So you program Mixer to do something, you program Envoy to do something, and that's the way it works. It's cluster local. So ideally, we want to move to a model where the operator is thinking in terms of features, and not in terms of components. So the user wants, the operator would like to impose a quota between two components, or would like to collect a particular metric or such things, as opposed to having to understand that Mixer is responsible for doing part of that, and Envoy is responsible for doing another part of the same thing. So this kind of thinking. In addition, part of our initial requirements for the work we're trying to do is eliminate emergent states in the system, which is an inherent problem in with Kubernetes. In the fact that pushing resources into pushing new configs is inherently non-transactional in nature. So you push and eventually consistent. So you end up pushing configs. They show up at different rates in different systems, and the system experiences an emergent total state that's unexpected, that can lead to failures and transient failures at least. So we ended up with this kind of model. I'll ignore the first box, the light gray box, and we'll talk about that afterwards. But effectively, we recast the configuration for Istio in terms of a service config resource. So that's all the state that's necessary to describe the behavior of a single service is captured in that one resource, and that so that includes.
You are still presenting in Zoom.
Okay, so Hangout just dropped out. Whatever. Okay, so all the state necessary to describe a single service is captured in the service config. That includes how to configure the mixer, how to do the routing rules that are applied, the different policies, the adapter parameters. All that stuff is in one file that can be introduced into the system in an atomic transactional way. From that single file, we will convert those into a number of component-specific things. So we go from the user's intent to exactly what the mixer needs and exactly what the proxy needs and the broker and the other components we're creating. This transformation is first done in a cluster agnostic way. So kind of generically, this is how the system should work. And then finally, it's delivered into, transformed into a cluster-specific set of configs that are delivered to the individual components. So that's taking the high-level intent of what the system should behave as and adapting it to the reality of the cluster's physical topology. So that's kind of the general transformation pipeline. Moving back to the left of the diagram, it shows this intent config. And this is effectively a utility layer and a usability layer on top of the service config. And it provides composition on top of the core, the basic abstraction. The idea is the operator can create a bunch of small configs, compose them together to create the larger service config. And the reason this is useful is that this now allows sharing. So you can have multiple service configs that are built out of the same core parts. So effectively, you can compose a bunch of configs and produce a variety of service configs out of them. So this is how, at the mesh level, somebody can say, "Hey, I'd like all of my services to collect the same set of metrics." So you put that in a little shared thing that's inherited, that's used by all the different service configs. And so you can apply policies horizontally that way. So in today's Istio world, we do some of that at runtime. So in the case of Mixer, we have these global resources and these per service resources, and the proxy just doesn't have an equivalent at this point. This model makes it so the composition is done completely offline, effectively from the runtime of the mesh, and we normalize that into a service config file. All right, so that's kind of the general data flow. In terms of components, what we're looking at is this thing. So starting on the top left, again, the operator is producing these intent configs. So again, those are these small little pieces. They're kept in the user's, probably in the user source control system, and the user then runs a tool to consolidate all those and output service config files. It's also possible there's a dotted line going from the operator straight to the service config file. The operator can write their own service config file by hand if they want. They can run orthogonal tools on the outside of Istio to produce these files if they want. You had I think you had an example of a tool yesterday that could be used to compose things together, transcode or something.
KSON?
KSON, yeah, KSON. So the operator composes somehow these service config files. They get delivered as CRDs, as resources into Kubernetes API server. On the receiving end, Galley is a webhook for the API server, so it gets these configs. So, oh, by the way, so the compilation step on the left side is expected to perform all sorts of validation. Semantic correctness, referential integrity check, and there's I've got a list at the top there, five different things, I think. So the service config file is assumed to have undergone a number of these checks already, so it's got a certain amount of certain level of correctness kind of built into it. It's self-contained, so it doesn't contain references to other resources. So you can reason about it in isolation. That gets pushed to the API server. The API server sends that to Galley. Galley performs second level validation for this stuff. And finally, the resource is accepted and injected into the system. So when that happens, Galley then takes the incoming resource and starts basically slicing it in terms of components. So understanding what the config is trying to do, and then just figure out what part goes to proxy, what part goes to Mixer. I show a box going from Galley to storage. It's not clear whether that's actually needed, but from a practical standpoint, that would just be a cache to avoid doing the same transformations again. So Galley is logically stateless. It takes the inputs and produces in a direct function, produces the component level configs. But these component level configs are cluster agnostic, so they're not aware of the topology of actual clusters. That's where the next phase comes down. Galley distributes the config to pilots. Pilots are running in each cluster. And in this model, the mission of Pilot the purpose of Pilot within the global Istio context is its scope of influence is increased. So Pilot is now responsible for delivering all the cluster config with all the config within a cluster. So it already is building a model of the cluster topology to program the proxy. In addition, here would also use that same knowledge to figure out how to program Mixer accordingly. So the protocol between Galley and the Pilot and the components is specifically not CRDs. It's something to be designed. The idea here is, I think we've been told that there's a limit to how much the API server can scale, and these are really not user. This is not user state. This is really system runtime state. So the model for the API server is not quite right for what we need here. So once Pilot gets in the picture, it kind of lowers the config to what the cluster needs and doles it out to the individual components running in the system. So that's kind of the general flow and the general responsibility of all the pieces that we're looking at. And in addition to just a raw distribution, there is the, and I don't know if I finished any site with useful diagram. Not that useful, but we're looking at how to do a stage rollout of configuration so that you can introduce configuration changes gradually within the system and instead of as a big bang. So the goal here is to do what we started to call kind of resource blending or config blending, which says the compiler can be given 2 different versions of config. Say this is the old one, this is the new one, and the compiler will produce a blended config, a blended service config that contains the states for both. That state, that blended service config then gets distributed instantaneously through the cluster, through all the clusters. But by default, or by nature of this process, the new, so you're going from an old to a new config. Both are blended together and sent down to the system. But at runtime, as the system is looking at this new config that's incoming, by definition, by the nature of this protocol, all the components are going to use the old config, even though there's a new one sitting there. So the idea is this is kind of to eliminate the eventual consistency problem. We first distribute the config to everybody and wait to ensure that everybody's got the new state. And then we'll start to gradually using the new config throughout the system. So the way we use this new config is basically at the top of the, when a request enters the system, there's going to be a small algorithm that's running in the proxy to decide, hey, am I going to use config A or config B for this request? Typically, the algorithm is just going to be a random number generator applied over a percentage of requests. So 10% of requests use A, 90% use B. The specifics of the algorithm doesn't really matter. But there's a selection that's made of which config to use, and that selection is sent down, used in proxy, used in Mixer and other interested parties in the system. So. And that's how we achieve a smooth transition from A to B. So the algorithm gradually is tweaked so that you start at 10%, 20%, 30%, 49%, up to 100%, and then at some point all your traffic is using the new config. Once you're on that step, once you're in that phase, then we can deliver another config throughout the system that is no longer blended config, but only contains B. So that last step again has no effect on the behavior of the system except for reducing a little memory consumption by removing this redundant caching, redundant config state. So right now, as I mentioned in the beginning, the only thing Istio actually does is this is the cluster-specific component config. We're figuring out the strategy to get this rolled out. So one of the efforts we're doing now is starting to express the config at a higher level form. So it'll be more suitable to be applied inside a service config directly. So it's no longer component specific, it's more abstract. The next step after that is figuring out how to compose these things into these little itsy bitsy pieces so we can have the intent level config as a source of input to the system. In practical terms of getting moving forward, the first step is what the work that Oz is doing today of getting a galley in the system that performs no transformation and doesn't involve pilot in the scheme. So it basically is going to ingest some configs, spew them back out, and get them into the system. But so it's not very useful, except that it gets it in the pipeline. Once that's there, the next step is probably to start changing the input format to be more the service config and the intent config stuff. So that's on my to-do list is to sit down with folks and come up with the actual list of the different click stops that we want to do over the next 6 months there. So, and that's about it.
So Matens doc is available in the in the drive. So if you have questions, feel free to. I think they can comment on this.
Yes, please.
But I have some questions regarding the architecture graph. The architecture graph. So this looks like the Kubernetes API server is in fact per cluster. So I'm not sure why it's the other side of the cluster box.
Well, the reality is there's
And my view is Galley is also like a per cluster configuration and API. I don't see like really Galley sits above the cluster. So I don't know how that's gonna work.
yeah. So there's a couple things. First, we do want to support a multi-tenant design where Galley is actually controls many meshes. So that there's our partners and us, we want to do these hosted scenarios. So architecturally, the model has to be that Galley is not directly in the mesh, but can affect the meshes.
So then the arrows between Kubernetes APIs, because Kubernetes API server doesn't really sit above the cluster. It's a per cluster.
Yeah.
So it's I don't know how practically it's gonna we can get into the model like this.
So this is a logical representation of the composition. Clearly, in a typical deployment where you don't have multi-tenant, Galley and the API server will be in a cluster, as opposed to necessarily being in every cluster. So I think.
But then Galley won't be able to find the other clusters to config.
Yeah, so there's an assumption that there's we've been. I don't want.
So I think it would be nice if we can kind of split the concern of multi-tenant Galley with maybe the first step of Galley, that's the single tenant Galley. So we kind of sorting out the single tenant Galley, and then we talks about how multi-tenant gonna work in here because the Kubernetes API server is not multi-tenant and they don't really sit above the cluster, and they rely on add-on components like a cluster registry to be able to find multiple cluster to addressing different clusters. So I mean, at least I see in near term, we probably cannot get this work.
Okay, so we can talk about it. Draw out a whiteboard here. It's not that far from what we need. I don't think this meeting ends in 2 minutes, right?
Yes.
Yeah. Okay.
So yeah, in 2 minutes, any questions from the community?
So I see this as marked as work in progress.
Yeah.
What does it mean that are we, in terms of knowing there's something that people agree on the general approach and specific work items? How do you see that working?
Well, we've generally agreed kind of the role, ignoring the issues of the cluster affiliation there. We've agreed on the role that there's these different pipeline steps and the transformation that's happening. So we're trying to move in that general direction immediately while the details are still, the final details are being worked out. I think it is basically kind of, from this perspective, no regrets moves. We know enough that we can do these things, and as the design refines itself, we'll know.
So what is it? Would we expect this to be approved at some point, and what does that mean? Is that supposed like here's the thing's actually built and we've approved it, or
no. So
there's a wider audience that
correct
will want to accept this.
Yeah. So I'm hoping we'll have some more discussions, refine the details, and address the problems within the team.
Yeah.
And then we need to go. This is Istio-wide, so we're going to need to have a real design review with the community as a whole and get feedback.
We expect to have some.
There's going to be a lot of
some of the code is already in progress. We're not waiting for this to be approved before. I know Oz and
have done some changes so far. We're not expecting.
We haven't done any changes.
Yeah, I mean, you're
No,
not saying like it's approved. Okay, now we can start doing the real work, right? We're continuing assuming this is
Yeah,
more or
the-
less
the-
going to work out. And
Exactly. So I think we know the general direction. We've already discussed this. Sven was in the discussions, Louis was in the discussions, and stuff. So I think there's going to be a decent. The core is not going to be contentious. The details of exactly the protocols and that kind of stuff. So that's what we need to argue about. I think I do expect a lot of discussions to come.
So any questions? Any more questions?
Oops.
Okay, no more questions. Thanks for attending. Please write comments to the doc. All right, bye.
Thank you very much.